Good day everyone, my name is Prabhakaran son of Kalayarsan. My metric number is CE200075. In this video, I would like to present about the smart wireless EV charging system that I have developed for my final year degree project. Now let's see the project overview. The proposed project is to change the current EV charging method to wireless charging. For that, this project uses inductive wireless power transfer technique to achieve wireless charging. And the proposed project is to develop mobile application to monitor and control the charging process. Okay, let's see the problem statement of this project. First is lack of easily accessible EV charging facilities. Especially in Malaysia, it's really difficult to find EV charging facilities in rural areas. So the EV user need to go to the cities to charge their EV cars. Next, sometimes the EV user needs to bring along the cable to charge the EV cars. This is because not all the EV cars use the same type of the cable. There are different type of the cable for the different model of EV cars. So the user should bring their own cable to charge their EV cars. This image here shows the example of EV car cables. And then the regenerative braking system is not effective for long distance use. Actually, the regenerative braking system is a system that can convert kinetic energy to electrical energy. So the regenerative braking system can restore energy from brake usage of EV cars while driving. Even though it can restore energy, but it cannot restore full energy. So the user still need to charge the EV cars. And it's also may be useful for the short distance but not very effective for long distance use. The objective of this project is to design inductive wireless power transfer circuit using MATLAB and then to develop a smart wireless EV charging system using inductive wireless power transfer technique. After that, to create real-time sensing and monitoring smart wireless EV charging system using IoT based. Next, scope of project. These are some hardware and software that used in this project. The first is ESP32 microcontroller, which is used to control the parking spot circuit, and ESP8266 is used in EV prototype system. The ESP32 CAM module is used to monitor the parking spot, and the coil is to achieve the inductive wireless power transfer. An IR sensor is to detect the presence of the EV in the parking spot. TP4056 charging module is to charge the lithium-ion battery. And the MATLAB software is to simulate the inductive wireless power transfer circuit. And the Arduino IDE software is to program the microcontrollers. And for the MIT app inverter is to use to develop mobile application. And then ThinkSpeak is to store the data that collected from the EV prototype system. Okay, let's see the methodology. This is the block diagram of this project. This block diagram is for the EV prototype, and this block diagram is for parking spot, and then this block diagram is for the Android mobile application. This project uses inductive coil to transfer power between these two circuits, and then the infrared sensor is to detect the presence of the EV in the parking spot. And this project also uses ESP32 CAM module to monitor the parking spot via mobile application. And then there are also Android mobile application is developed in this project. Okay, this is the flowchart of the system. This image shows how sensor detect the presence of EV and activate the ESP32 CAM module. And then this image shows ESP32 CAM module is activated and how it starts the stream on app. After rear sensor is detected the presence of EV, it will start the charging process, which user need to choose the start charge button on the app. It will activate the transmitter coil and start charging, and also user can view the battery percentage and voltage on app, and also can stop the charging option. Okay, now let's see the circuit diagram of this project. These are the circuit diagram used in this project. This image represents the parking spot circuit, and this image represents the EV prototype circuit. After that, result and discussion. This is the wireless power transfer simulation circuit that designed and simulated in MATLAB software. And this image shows the result of simulation. This is voltage received at the receiver coil over time. Okay, let's view the result of this system. This system is start with positioning the EV prototype at the parking spot, and then activated the ESP32 CAM module to stream the parking spot. After that, continue with charging process, and finally display the battery percentage and battery voltage on the mobile application. This image here shows the parking spot sensor circuit was developed and tested. So in this testing, the object used this ruler. This represents the EV prototype. So if the sensor 1 and sensor 2, which is front sensor, detected the object, it will activate the relay, which relay connected to the ESP32 CAM module. If all the 4 sensor is detected the object, it will deactivate the relay to turn off the ESP32 CAM module. So this image shows the parking spot on the model, which is sensors are installed in, and then transmitter coils are installed. So this image shows the EV prototype is entering the parking spot. The IR sensor 1, IR sensor 2, which is front sensor, is detected the presence of the EV prototype. We can see here the LED on the IR sensor is 2 LED is light up, so it means the sensor is detected the presence of the EV. So now it will turn activate the ESP32 CAM module. This is the result of camera streaming. So ESP32 CAM module was tested before it's installed to this model. So if the EV prototype is entered the parking spot, the IR sensor is also detected the present. So the system will activate the ESP32 CAM module, and then the user can view the parking spot on the mobile application by clicking the start camera option on the app. And this image shows the output, which is result camera streaming on the app. Okay, let's see the result of charging process. So when the EV prototype is fully entered the parking spot, the front sensor and rear sensor will detect the presence of the EV prototype at the same time. So if the all 4 sensors detected the presence of EV prototype at the same time, it will deactivate the ESP32 CAM module and stop the camera streaming. So now the EV prototype is ready to charge. So the user need to click the start charge option at the mobile application. If the start charge option is clicked on the mobile application, it will start charging on the prototype model. As we can see here, the LED light up inside the EV prototype. This means the charging process has been started. So this image shows the battery level, which is battery percentage, shows on the top of the EV prototype, and then this image shows the battery voltage as displayed in the OLED screen. As for the last part, the system will display the battery percentage and battery voltage on the mobile application. So if the user click the battery level option on the mobile application, the system will display the battery percentage and battery voltage at the mobile application in real time. There is also a graph option, so the user can see the battery percentage in the graph option in the graph form, and there is also battery voltage in graph form. Conclusion. As a conclusion, the smart wireless EV charging system was successfully designed and developed in its project. The smart wireless EV charging system gives real-time data monitoring and controlling system of the EV charging process via Android mobile application. Thus, the system has capability to minimize the current EV charging issue by introducing wireless EV charging method. Hence, this system can provide reliable, practical, and conveniently accessible charging opportunity. Okay, let's see the recommendation of this project. The first is notification element should be added to the system so that the system can notify the user through the mobile application. If the system notifies the user will be more aware of this charging process. And then the admin and user login system should be included with this system. So the system will be more secure, and if any malfunction occurs in the system, it will appear on the admin page, so the admin can take action to solve the problem in the system. After that, improve inductive coil. To improve the inductive coil, this system can be tested with different type of different shape of coil and different size of coils to provide a fast charging option to the users. And finally, can add pricing option to the system. To implement this wireless EV charging process to the real world, the pricing option should be included to this system so that user can choose price to charge their EV cars. That's all from me. Thank you.